All right, we got some vocabulary here. We've got consistent lines and inconsistent lines. Let's start with the inconsistent. Inconsistent, the prefix in means not. So inconsistent are systems that don't have a solution. There's no solution. So one way you can remember it is inconsistent means not consistent, and there's not any solution. What kind of system do you have? What kind of lines do you have if you have no solution? Let's go with parallel, and why don't you go and draw those so we can see it. So if you have parallel lines, you have an inconsistent system. There's no solution. Well, the opposite of inconsistent is consistent. That means you do have a solution. But remember, there's two ways we can have a solution to a system. You could have one solution, or you could have how many? Infinitely many. So we're going to distinguish between the two. So a consistent solution is you have at least one solution. If you have exactly one solution, it's called independent. And if you have infinitely many solutions, it's called dependent. So if you have exactly one solution, it's an independent system. Graphically, what kind of lines do you have? Excellent, it's intersecting. So you can just draw a couple lines that intersect there. And they don't have to intersect at a 90-degree angle, all right? They could. All right, if you have infinitely many solutions, it's a dependent system. And what kind of lines are those called if you have infinitely many solutions? You have a line, and you have another line right on top of it. Excellent, you got that vocabulary word. It's coincidental. This may help with the vocabulary. If you have coincidental lines, you have one line, and then you have another line on top of it. If I move one of the lines to remain coincidental, what does the second line have to do? It has to move with it. So the first line is dependent on the second line, or the second line is dependent on the first one. You could use that memory technique to remember what dependent means. It means that if you move one line, you got to move the other line so they're coincidental. Versus independent lines, let's go ahead and here's an independent system. You have two lines, they intersect once. If I decide to move that red line, it's steeper slope. Do you have to move the second line? No, you don't have to. That line can stay where it is. Okay, same slope. So if you move one line, you don't have to move the other line. You could use this memory technique to say, hey, the two lines are independent. It doesn't matter what the first line does. The second line can stay put, or vice versa. The second line is independent of the first line. But to be technical about it, the independent and the dependent have to do with the system. All right, so let's go to number 2 here. We're going to find out how many solutions there are and then classify it as either consistent and independent, or consistent and dependent, or just inconsistent. Notice if it's inconsistent, there's no solution. All right, so let's go ahead. What's the x-intercept on this one? 4/3, you got it. And for the y-intercept? -4, okay. So you've got 4/3 for the x-intercept and -4 for the y-intercept. I'm going to go ahead and count that. Notice that it's up 4, right 1 1/3. Up 4, right 1 1/3, so it goes about right there. Draw our line best as you can. The x-intercept for 3x minus y equals 4. 4/3, and the y-intercept you can do -4. So look at this, 4/3, -4. Whoa, what kind of lines are they? Coincidental. Since the lines are coincidental, the system is what and what? Good, it's dependent and consistent. Consistent and dependent. It's consistent because there's at least one solution, and it's dependent because they're coincidental lines. And has how many solutions? Infinitely many, you got it. Don't just put many, because many means there's a lot, but you can count them. There's an end to this number of solutions. Infinitely many means there's no end to it. And you can see with the arrowheads, you can see that there's infinitely many solutions.